Hello. So we are going to learn about trigonometry today. So the very basic thing about trigonometry is it is finding the value of an angle of a right angle triangle. Now this is very important. It's for a right angle triangle with the ratio of its sides. Okay. So for example, ABC is a right angle triangle and theta is an angle. We don't know the value, that's why we have used a variable known as theta. We can use any other variables as alpha, beta, a, b, c, gamma, lambda, etc. Okay, so here at angle B we have our 90 degrees and the side opposite to 90 degrees is known as the hypotenuse. Its value is the largest in any right angle triangle. If a triangle's hypotenuse is not the largest in the triangle, that means that kind of a triangle is not possible or cannot be constructed. Now there are 6 main ratios of sides which we use to find out the angle. Those 6 ratios are sine, cosine, tangent, cosecant, secant and cotangent. Their short forms are sine, cos, tan, cosec, sec and cot. Now the side opposite to the 90 degrees, as I told you, is known as hypotenuse. Now we have to take the angle into consideration. If I consider and solve for angle C, then angle C will be theta. And according to C, whichever side is opposite to this angle is known as the perpendicular and the side adjacent to it is known as the base. Now it's all about the remaining two angles. For example, if I change the angle, the values will change. If I am using angle A, that time the perpendicular will be the one opposite to the angle and the adjacent will be the one next to it. Okay. Now, hypotenuse does not change. The value of hypotenuse will never change, as it will always be the side that is opposite to the 90 degree angle in that triangle. Now, there are some important ratios as I told you, and their values are sine theta is perpendicular upon hypotenuse. Also, it is the reciprocal of cosec theta. So sine theta is equals to perpendicular hypotenuse, also equal to 1 upon cosec theta. Cos theta equals to adjacent upon hypotenuse, which also equals to 1 upon sec theta. Tan theta equals to perpendicular upon adjacent, which also equals to 1 upon cot theta. Cosec theta, as we have seen, is the reciprocal of sine theta. Therefore, its value will be hypotenuse upon perpendicular. And sec theta, it will be 1 upon cos theta and its value will be hypotenuse upon adjacent. Now tan theta and cot theta have two different values. For tan theta it is sine theta upon cos theta, and cot theta it is cos theta upon sine theta. These all are proven ratios which will never change. Okay. Now when we square these ratios, the ratios we have seen previously will apply all the same, but a few new ratios will be formed, which are as follows. Sine theta plus sine square theta plus cos square theta equals to 1. Sine square theta equals to 1 minus cos square theta, while cos square theta equals to 1 minus sine square theta. At the same time, sec square theta minus tan square theta equals to 1. And sec square theta, this is just editing or algebraical use of these equations. When I shift this cos square theta to the right hand side, it changes its sign to minus, and therefore we get these two different equations when we apply the same thing for sine square theta. Same thing over here, sec square theta minus tan square theta equals to 1 is the main ratio, while sec square theta is equals to 1 plus tan square theta. Tan square theta is moving to the right hand side, and tan square theta equals to sec square theta minus 1, where I'm shifting the minus tan square theta over here and shifting 1 to the left hand side. Next is cot square theta minus cosec square theta equals to 1, where cot square theta's individual value will be 1 plus cosec square theta, and cosec square theta's individual value will be cot square theta minus 1. These are the standard ratios that you have to remember, and they will be used in all types of sums that are going to follow. So please write these down, pause your video and note them down. Be very ready with them. You should not forget. Now there are some examples. So I've taken one sum which will explain all types of changes. Now as it is a right angled triangle, we in some cases are going to use the Pythagoras theorem. If you don't remember what is Pythagoras theorem, it states hypotenuse square equals to side 1 square plus sides 2 square. These side 1 and side 2 are the remaining sides. Now here the sum says sine theta equals to 4 upon 5. Okay, they have given us values and they have told to find out the remaining ratios that are cos theta, tan theta, sec theta, cosec theta and cot theta. Now how will we do this? Now we know sine theta equals to perpendicular upon hypotenuse. That's the formula that we have seen over here, perpendicular upon hypotenuse. So we get the value, we compare the values, perpendicular upon hypotenuse. Therefore perpendicular becomes 4, hypotenuse becomes 5. I have drawn a figure, I have marked my theta. According to this theta, the side opposite is perpendicular, so its value will become 4. And the side that is opposite to the 90 degrees is hypotenuse, so its value will be 5. But the adjacent, or you can also call it base, is missing. So how will we find out this base? We will use the Pythagoras theorem to find the missing side in a right angled triangle. Okay. So Pythagoras theorem states hypotenuse square is equals to side 1 square plus side 2 square. So here hypotenuse is AC. So AC square, perpendicular. Now side 1 is the perpendicular, which is AB square plus BC square. Now I have just put in the values of AC and AB, and BC's value is not present. So 5 square plus 4 square plus BC square, 5 square is 25, 4 square is 16, plus BC square is missing. Now 25 minus, I have shifted 16 over here, so 25 minus 16 will be equal to BC square. BC square equals to 9. Therefore, I'll take root on both sides of the equation. So BC square root will become BC and root of 9 will become 3. So I have found my missing side, that was BC. Now I can use all the given values and ratios, where if you see properly, sine theta equals to 4 upon 5, which proves the formula perpendicular upon hypotenuse. Along with that, 3 upon 5 proves adjacent upon hypotenuse, while 4 upon 3 proves adjacent upon perpendicular upon adjacent. The next one proves that it is cosec theta, so it proves that it is reciprocal of sine theta, which is hypotenuse upon perpendicular, and sec theta proves it is hypotenuse upon adjacent, and cot theta is reciprocal of tan theta, which is adjacent upon perpendicular. If we see all the formulas here, they are one and the same. You can pause these 2 frames and check both the formulas. If you see, these formulas are applied in the same way. So here cot theta's formula is missing. Cot theta's formula is adjacent upon perpendicular. Next, we have the trigonometric table. This table is fairly easy to make. You don't need to remember it. It's very easy to make. So we find out, now as we were talking about angles being found out due to with the help of sides. So now we will apply the actual values to the actual values of angles. So there are some angles whose values are fixed or come in a fraction. Those angles are most commonly studied for your portion. Those angles are 0 degree, 30 degree, 45 degree, 60 degree and 90 degrees. For them, it's a fairly simple method. First, you will give the serial number 0, 1, 2, 3, 4. You will divide all those serial numbers by 4 and then you will take a root of all of them, which will leave you with these values. These values, when solved, will give you the answer of sine theta. So sine 0 degrees is 0, sine 30 degrees is 1 upon 2, sine 45 degrees is 1 upon root 2, sine 60 degrees is the root 3 upon 2 and sine 90 degrees is 1. Cos theta is the exact opposite in values. So if you see, I have just written the values of sine theta from right to left. 1, root 3 upon 2, 1 upon root 2, 1 upon 2 and 0. Next is tan theta. If you see, we had seen a formula. Tan theta is sine theta upon cos theta. Therefore, tan theta becomes 0. You will solve for sine theta upon cos theta. 0 upon 1, 0. 1 upon 2 whole upon root 3 upon 2. 2 will be cancelled. Answer will be 1 upon root 3. 1 upon root 2 divided by 1 upon root 2. Same number divided by the same number. Answer is 1. Root 3 upon 2 whole divided by 1 upon 2. 2 and 2, the denominators get cancelled. Answer is root 3. And the fourth one is not defined because 1 cannot be divided by 0 or any whole number cannot be divided by 0 in any condition. Cot theta is exact opposite of tan theta. So I have just written the values of tan theta from right to left here. Not defined, root 3, 1, 1 upon root 3 and 0. So I'm just starting the values like this. These values are like this and I'll start like this. Next is cosec theta, which is a reciprocal of sine theta, that is 1 upon sine theta. So I'll just do 1 upon to all the values of sine theta. 1 upon 0, 0. Reciprocal of 1 upon 2, 2. Reciprocal of 1 upon root 2, root 2. Reciprocal of root 3 upon 2, 2 upon root 3. And reciprocal of 1 stays 1. And same thing I have done over here with sec theta, that I have written these values from here. So 1, root 3 upon 2, root 2, 2 and 0. So this is a trigonometric table and this will be applied where you'll have to use these values for these angles only. So sine 60 degrees, root 3 upon 2. Cosec 90 degrees, 1 and so on. So this is an example sum for the same. Solved example. So 2 into sine square 45 degrees plus cos 45 degrees. So 2 into sine square 45. Sine 45, let's see in the table. Sine 45, which is 1 upon root 2. So I have put in the value as it is square of the entire value. So 1 upon root 2 square. 2 into plus 1 upon root 2. 2 into, now after squaring, while squaring this fraction, the square of a fraction happens separately. That means numerator and denominator both are squared. So 1 square is 1, root 2 square is 2. 2 into 1 upon 2. So 2 upon 2 plus 1 upon root 2. This stays. 2 upon 2 becomes 1 plus 1 upon root 2. After solving the fractions, that is making the denominator same, the answer comes root 2 plus 1 whole upon 2. Then I have factorized the denominator. Either one of these, this or this, both could be the answer. It's not compulsory to factorize. So this is the very basics of trigonometry. I will send in another video later talking about the trigonometric identities. So these are the main trigonometric identities. Using them, we are going to solve a few equations. We are also going to use identities like this: 1 upon cosec theta, 1 upon sec, 1 upon cot. So that is sine equal to this. We are going to use all of this material and solve a few equations. I'll send in a video of that later. All the best.